Assalamualaikum. We are here to present our project, which is nuclear radiation detectors. The basic aim of our project is to design the radiation detectors which can be used at the borders, transport stations, seaports and the airports so that the illegal traffic and transportation of illegal nuclear material can be avoided. Our presentation contains the comprehensive discussion including introduction, market, technical, financial, socio-economic and ecological appraisal of the whole project. Here are the contents. In contents we will discuss introduction. In introduction we will discuss what are the detectors, type of detectors, mode of operation, and then we will discuss different characteristics. At the end we will discuss different appraisals such as market appraisal, technical appraisal, financial appraisal, socio-economic appraisal. At the end we will discuss applications. Detectors are the devices which upon encountering some radiations give some signal in the form of some alarms or light. What happens is that when radiations falls upon the devices, they excite electrons which give small amount of current, which is our requirement. Here are some characteristics of the detectors. Sensitivity of the detectors determines how much electrons or neutrons are generated for the incident radiations. Energy consumption of the detector determines how much energy the detector needs for its proper functioning. For example, this energy may be 0.05 to 5000 electron volts. Response time of the detectors must be fast to the input radiations. Efficiency of detector determines the measure of its ability to detect radiation. It is basically the product of geometric efficiency and intrinsic efficiency. Here are some types of detectors. Gas field detectors have gas field between two electrodes. Scintillation detectors have ionization radiation produce ultraviolet or visible light. Semiconductor detectors are especially made up of germanium and small traces of other impurities so that they can act as diodes. Detectors may be also classified by type of information produced. For example, Geiger-Müller counters may detect the number of interactions occurring in detectors. Detectors that yield information about the energy distribution of the incident radiation, such as sodium iodide, can be called as spectrometers. Detectors can also be utilized to find out the amount of energy deposited in the detectors. These are called dosimeters. Here are some snapshots of detectors. Now we will discuss mode of operation. Basically, detectors operate in two modes, in pulse mode and current mode. In pulse mode, the signal from each interaction is processed individually. In the current mode, electrical signal from individual interactions are averaged together, forming a net current signal. Now we will discuss different properties such as interaction rate. Interaction rate must be separated by each other by infinite amount of time to produce distinct signals called dead time. Otherwise, the second interaction may be lost, causes the distortion of the first signal. This is called interaction rate. Now comes dead time. Finite amount of time that a pulse takes to be separated from other pulse to avoid distortion. For example, GM counters have longest amount of dead time ranging from 10 to hundreds of microseconds. In current mode operation, charges are collected in the form of current, and it is supposed that charge collected from each interaction is proportional to the energy deposited by the interaction. This current describes the dose rate absorbed by the detector material. Let's come to the market appraisal. In market appraisal, we will discuss technologies that are being used in market. In this technology, we will discuss different types of detectors which are used in market. Number one is radiation pagers. These are small in size. These are like shape of page. These may be have short ranges of detection. Now come radiation portal monitors. These are made up of plastic scintillator material. These detectors are capable of detecting radiation coming from vehicles. So these are used for vehicle monitoring. Radioactive isotope identification devices. These are handheld devices. These devices also have short range of detection. Radioactive imaging systems. These are used in ships loading cargo containers. These devices generate high energy photons that are sent to the cargo containers and the radiographic image of the containers loaded. The radiograph is scanned by the operator or automatically to search for the nuclear weapons hidden under papers or other materials. Now comes to the market demands and share of the detectors. According to one survey of nano market suggests that by the year 2016, the market of the radiation detectors will contribute $2.7 billion. Among these, scintillation-based radiation detectors contribute 70% of the overall market. This graph shows the contribution of scintillation radiation detectors, which determines 70% of the overall market share and 30% is shared by others. Past and current demand trends. Demands of the radiation detectors have been increased vigorously since the last decade due to the threats of terrorism than the past trends. Imports and export. Export of these detectors was approximately null in the past. Most of the devices were imported, but with the start of this project, current market demand would be fulfilled as well as export would be increased, contributing 10% increase in the benefit to the country annual revenue generated. Now we'll discuss distribution channels. Past distribution policies were not effective to provide the services to the volunteer customers, and they did not fulfill the demands as those products were designed in small amount. But now our main aim is to provide customers satisfactory products within reasonable amount of time. Now discuss legal and other constraints. Since legal constraints are always there in every type of business, that's why our main constraint is the misuse of the product. Our main focus is to provide the material only for the studies and researches. All the copyrights are preserved to our firm only. The supply or the demand of the product is totally dependent upon the consumer behavior. The project consults maximum with the public needs and demands. Collaboration with the other industries was maintained to distribute and implement the new technologies. Nature of competition. Since detectors industry is growing rigorously, many new and innovative products are being launched with the demand and researches. Our main motive is to provide detectors having optimal efficiency and reliable to use. Elasticity of demand. Since supply-demand trends change with the needs of time, after some attacks, this trend may increase rapidly. So it is not smooth. Our aim is to keep this trend stable so that our products may always remain in the international market. Now we will discuss technical appraisal.
Technical appraisal. In the technical appraisal, we will consider many factors that include line requirements, availability, technological layout, communication layout, and organizational layout. The factors that we will consider in the technical appraisal are transportation network, earthquake, geological faults, availability of labor, rivers and floodways, environmental resources. The company working area is 20 hectares and nuclear installing areas is 0.1 hectare. In the technological layout, we have nuclear radiation source that emit the radiations, and these radiations are detected by the nuclear detector, and after detection we will get red signal or the buzz. In the communication layout, we will provide the internet connectivity and the telephonic services, walkie-talkies, and basically walkie-talkies in our organization are used for the security purposes. In our organization, there is one vice president that leads the marketing department, financial department, construction department, and quality improvement department, customer service department, human resource management department. In the construction department, we will have electrical engineering, mechanical engineering, electronics engineering, nuclear engineering, and atomic engineering. In the transport layout, we will have the transportation, and the transportation distance between the company and market is very little, and the raw materials are easily available from the nearby places, and company is located in the area where the road transportation is very easy. And now we will study the financial appraisal.
Finance is required under financial regulations to check that suppliers of goods and services can demonstrate a stable and appropriately substantive financial background. We also have made a financial appraisal of our project. This first table shows the total cost of the project and also the subdivision of this cost to different processes and the working units. The total cost of the project is 590 lakh rupees, and this is allocated to different processes which involve land and site development, building and civil work, technical equipment, know-how and engineering fees, miscellaneous assets, preliminary and pre-operative expenses, working capital margin. This is the graphical representation of the distribution of the total cost. The land and site development cost 150 lakh rupees, and this is allocated for the purchasing of land and the site development, which involves leveling the plot, laying of factory road, construction of boundary walls, construction of main gate and tube well digging. Construction of building and civil work require 170 lakh rupees, and it is allocated for construction of main factory, building administrative office, construction of go down and civil work for utilities. The technical requirement cost 40 lakh, and this cost is further subdivided for the processes or the equipment which involve ionization chambers, proportional counters, GM counters, scintillation detectors, materials, photomultiplier tube amplifiers, miscellaneous things, and these all above cost 33 lakh. But along with tax and duties, which is 10%, it becomes 36.2 lakhs, and along with sale tax, which is 2%, it becomes 37 lakh. And then when we count the loading and unloading cost and the commissioning cost, it becomes 40 lakh. The technical know-how fees involves the cost of the training, which is used to train people so that they can use equipment. This cost is 10 lakh rupees, and it is allocated for the expenses on foreign technicians, know-how and engineering fees, royalty and compensation payable. Miscellaneous fixed asset is 100 lakh rupees, and it is allocated for laboratory equipment, testing equipment, furniture and office equipment, radiation treatment equipment, and payment for license. The calculation of preliminary and pre-operative expenses is 20 lakh rupees, and it is allocated for consulting charges, rent, tax and rates, promotional expenses, organizational training cost, postage, telephone, telegram, and printing and stationery. We take financial support from financial institutions, from bank and from government, and it total becomes 10 crore. The monthly salary estimation is 180 lakh rupees, and it is further subdivided into technical main force, managerial staff and security staff. Now socio-economic appraisal will be discussed.
In the socio-economic appraisal, we will consider social cost benefit analysis, capital expenditure estimates of the project, calculation of social values, projected annual profitability statement. In the social cost benefit analysis, we will consider three factors that are economic rate of return, effective rate of protection, and domestic resource cost. In the capital expenditure estimates of the project, we will consider the land, building, plant, machinery and many other factors. And the land amount is 150 lakhs, building is of 170 lakhs, plant and machinery is of 40 lakhs, and transportation cost is 1 lakh, and technical know-how fees is 10 lakh. Pre-operative expenses are 20 lakhs. In the calculation of the social values, we will consider first of all a tradable value whose value is 10 lakhs, social cost of tradable component is 9 lakhs, and social cost of labor component is 5 lakhs, social cost of residual is 3 lakhs. In the project annual profitability statement, we will consider income, net sales, expenditures, raw materials, labor, salaries, repairs, their maintenance, and fuel, depreciation, other valuable. At the end, we will consider taxable profit. Income is 740 lakhs, net sales is 699 lakhs, expenditure is 10 lakhs, raw material is of 24 lakhs, labor is of 5 lakh, and salaries are 180 lakhs, repairs and maintenance are of 0.5 lakhs, fuel is of 0.5 lakhs, depreciation is of 40 lakhs, other valuables are of 0.5 lakhs, and the taxable profit is 34 lakhs. Now environmental appraisal will be studied.
Environmental appraisal. Our project is environment friendly, and in our environmental appraisal we are checking the impact of project on the quality of air, water, noise, vegetation, and consequently on the life beings. The area where this company is being established is a little bit far from the population because the equipment test involves radiation emission. But this is below the limit determined by law, and this is not contaminating the environment because it is according to the law. The experimentation is being done under controlled environment and proper precautions are being taken so that the air of the particular area do not becomes affected. Meteorology. The air is having the 4 different weathers, and observation has shown that there are high and low speed winds and temperature variation occurs too. The company operation doesn't involve any health hazardous waste that can contaminate the water of surroundings. The estimation have shown that the quality of water remained same before and after the construction and working of the company. The noise is being monitored at different sides of company and at different times, and it is being observed that even the peak hours, noise is below the standard limit. The area is mostly surrounded by mountains, so there is no particular type of wildlife, or also the plants are natural. That's why company construction hasn't affected the ecology. Demography and socio-economics. The project site is located in Texla, 10 km away from UET. The area has the population of 1,51,000. The literacy rate is not very high because this is a rural area. Mostly people are worker. Radiation detectors can be used abundantly. They can be used at borders for security purpose. They can be used to detect the material that are shielded and that can be transported through cargo ships. These detectors can also be used in custom buildings, in sensitive government buildings, airports, military offices, schools, colleges, parks, etc. These detectors are of small size. That's why they can also be used for investigation purposes. These detectors can also be used to locate the underground mineral resources. These are the references to whom we have consulted during our project. Thank you for listening.